Hello and welcome. For this fourth episode on carbon capture, utilization and storage, in short CCUS, let's talk about capture. A challenge since several billion tons of CO2 will have to be captured annually from 2050 to achieve carbon neutrality. Can this be achieved with currently available capture processes? To answer such a question, we have two experts, both key players in the field of CO2 capture. Vania Santos-Moreau, 3D Project Manager, and Stéphane Bertholin, Cheers Project Manager. Hello, Vania.
Hello.
Hello, Stéphane.
Hello.
Vania, you lead the European 3D Industrial Pilot, DMX demonstration Dunkirk, and this project will demonstrate the effectiveness of the DMX carbon capture process developed within IFPEN's labs for 10 years. Can you tell us more about this technology and its importance for industry decarbonization?
DMX is a post-combustion CO2 capture technology. This means that it allows CO2 to be separated from an industrial gas or a flue gas. The principle is simple. Bring a gas or flue gas containing CO2 in contact with a liquid, in our case, the DMX solvent. Thanks to the strong affinity between CO2 and liquid, the CO2 will pass from the gaseous phase to the liquid phase. Then, thanks to the action of temperature, the CO2 will be released from the liquid phase and separated. We thus obtained a very pure CO2, ready to be compressed and transported by pipeline or ship to the storage site, or ready for a second life to produce fuels or chemicals used in food industry or construction materials. The particularity of the DMX technology lies in the exceptional physical chemical characteristics of the DMX solvents, which make it possible to offer a very competitive process in terms of energy consumption. The industry needs this type of high-performance technology to reduce industrial CO2 emissions, which cannot be reduced otherwise. But DMX is not the only process that can effectively capture CO2. Stéphane, I'll let you talk about it.
Before you take over, Stéphane, I precise you are the leader of the Cheers project, a demonstration project also financed by the European Commission, and this project makes it possible to obtain at low cost a flow of pure CO2. That's right?
Yes, absolutely. The DMX process presented by Vania aims to capture the CO2 at the exhaust of existing plants to reduce their environmental impact. IFPEN is also working on future industrial plants which will be directly fit for CO2 capture. These new energy plants, dedicated to heat production, will use the chemical looping combustion, CLC, technology. CLC makes it possible to produce a very concentrated CO2 flux without additional stages of capture. The principle is based on the combustion with pure oxygen and not with air. That is to say, without large quantities of nitrogen that dilutes the CO2. In practice, a metal oxide is circulated, bringing oxygen and only oxygen to where combustion takes place to produce heat. To better understand, one can imagine the functioning of this oxide like that of white blood cells in the human body. The oxide first picks up oxygen in a reactor, like our blood cells picks up oxygen in our lungs. Then it circulates through another reactor to release oxygen as the red blood cells deliver to the organs that need it. We therefore have a very concentrated supply of oxygen for combustion, which allows the generation of flue gas composed solely of CO2 and steam water. Then we only have to condense water to obtain concentrated CO2, which can be transported and then used or stored for a long time. The CLC process, therefore, foreshadows a new generation of thermal power plants that will produce electricity, steam, or supply district heating networks without greenhouse gas emissions.
Thank you, Stéphane. The analogy with the human body is very evocative. Can you specify the industrial application of these different technologies?
The DMX process is currently being tested at the ArcelorMittal steel mill in Dunkirk. Our ambition is also to adapt the DMX process to emitters other than steel industry, refining, or waste treatment units, cement manufacturers. These industries produce flue gases of different compositions with different volumes of CO2. For instance, a steel mill site can produce 11 million tons of CO2 per year, while a cement plant produces an average 1 million ton per year. We are now checking that the DMX process adapts to different emitters. Taken together, these capture technologies will make it possible to reduce emissions to achieve carbon neutrality.
They could even do a bit more. For instance, using biomass as fuel in our CLC process. In this case, the carbon contained in the biomass comes from the atmosphere. It is CO2 that has ensured the growth of the plant. If we capture the carbon or the CO2 contained in the biomass, we then indirectly capture the CO2 coming from the air. We refer in this case to a process with negative emissions. We could also use waste as feedstock, such as carton packaging, which contain atmospheric CO2, or plastics that cannot be recycled. The CLC process will make it possible to produce energy from biomass or waste with a positive impact on the environment. It is therefore fully in line with IFP Energy Nouvelle ambitions for decarbonized energy future.
Thank you very much, Stéphane and Vania, for your explanations. That was another rich and exciting topic. I hope you enjoyed listening to this podcast, and if so, stay tuned.